Okay, in Unit 4, we'll be talking about exponential and logarithmic functions. They are very closely related. We're going to start first talking about exponential functions. So that's really what we will be talking about today is the exponential part. We'll get to the log part later. So we're going to talk about how do we graph these exponential functions. So the equation is going to look like y equals a b to the x, where now for the first time, the variable is an exponent. So let's take a look how we can graph these. All right, so here I have y equals 2 to the x, and x is my variable. So as we usually do when we start out, when we are graphing something for the first time, let's make an xy table. So let's pick some values. Let's start with 0, 1, 2, 3, and let's plug those in and see what happens. Well, if I plug 0 in for x, 2 to the 0 is going to be 1. Remember, anything raised to the 0 power is 1. 2 to the 1 is 2. 2 to the 2 is 4. And 2 to the third power would be 8. Well, let's see what happens if I plug in negative numbers. Let's plug in -1, -2, and -3. Well, if I have 2 to the -1, remember this negative sign has nothing to do with the sign of the number itself. It says, I don't want to be in the numerator. Please put me in the denominator. So this is really going to equal 1/2. So therefore, 2 to the -1 is 1/2. 2 to the -2 would be 1/4. And 2 to the -3 would be 1/8. All right, let's go ahead and graph these now, and let's see what this will look like. 0, 1, 1, 2, 2, 4, 3, 8. -1/2, and I'll just estimate it there. -2, 1/4. -3, 1/8. And you can see if I had more and more negative numbers, -4, -5, I would just be getting closer and closer and closer to this x-axis, but I would never actually touch it because there is no power that I could raise this to that would make this expression 0. So therefore, this is what my graph would look like. This is called exponential growth. Exponential growth. And it signifies by a quick increase here in your y's with a relatively small increase in x. So kind of just to go over that quickly, things you want to notice is that exponential growth refers to a rapid increase in y compared to a slow increase in x. The graph never crosses the x-axis, and we actually have a name for that. The x-axis in this case is what we're going to call the asymptote. And the asymptote is nothing more than a line that the graph approaches as x gets infinitely large or infinitely small. And you'll see these asymptotes on more of the graphs. All right, we started with the simple function y equals 2 to the x, but let's take a look at what y to the 3 to the x and y 4 to the x and what 5 to the x looks like and see how these might be different. So again, let's just start by making an xy table. Let's just do 0, 1, 2, and let's just do -1 and -2. If I go much higher, it's probably going to start to get off my graph. All right, well, anything raised to the 0 is 1. 3 to the 1 is 3. 3 squared is 9. 3 to the -1 is going to be 1/3, and 3 to the -2 will be 1/9. So let's go ahead and graph that. 0, 1, 1, 3, 2, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I'm going to have that -1, 1/3, -2, 1/9. And once again, I'm going to come down like this, and I'm going to get closer and closer to that x-axis. But you'll see here, my x-axis is actually my asymptote. So I'm going to actually draw my asymptote in now with a kind of a dotted line. So we'll see that this here is my asymptote. This is the line that it's going to approach but never ever touch. All right, let's see what y equals 4 to the x looks like. Again, let's start with 0, 1, 2, -1, -2. 4 to the 0 is 1. 4 to the 1 is 4. 4 squared is 16. Off my graph. Probably don't even have to worry about it. So 4 to the -1 will be 1/4, and this here will be 1/16. Now you're starting to notice then anything raised to the 0 power is 1. So all these graphs are going to have that point in common. So there's my 0, 1. Here's 1, 4. 2, 16 would be off my graph, but it would be way, way up there somewhere. Negative 1, a fourth. Negative 2, a 16th. So I'm going to come down here like this, and once again, I'm going to get closer and closer and closer to this x-axis, but never touch it. All right, let's take a look at y equals 5 to the x. Same thing. 0, 1, 2, negative 1, negative 2. Of course, this is going to be 1 because now we know anything to the 0 is 1. This here will be 5. This here will be 25. This here will be 1/5, and this here will be 1 over 25. All right, I'm going to share this point once again. 1, 5, 1, 2, 3, 4, 5, 2, 25. So now it's going to come like this. And again, negative 1, 1/5, negative 2, 1/25. It's going to come down. It's going to hug this asymptote. So you can see what's happening here as my base here increases. These graphs are going to get closer and closer and closer to my y-axis. And they all are still going to have this x-axis as your asymptote. All right. So again, just to review, these three graphs are all very similar. As the base gets bigger in the first quadrant, it's going to get closer and closer to the y-axis. The part in the second quadrant gets closer and closer to the x-axis, but you can't really notice the difference, and they share this point 0, 1. Let's see what happens now if our base, however, is not a whole number, if we have some sort of a fraction here, some sort of a fraction less than 1. So again, I have my XY table. Let's go ahead and put in some values. I'm going to start here at 0. If I put in 0, I know I'll get 1. If I have 1/2 to the first power, well, that's just going to be 1/2. If I have 1/2 squared, that's the same thing as 1 squared over 2 squared. So that'll be 1/4, and this here will be 1/8. If I plug in negative 1, well, that's going to be the same thing here as 1/2, except it's going to want me to flip it. So this is going to be 2, negative 2 will be 4, and negative 3 will be 8. So now you can see what's going to happen when we graph this. I have negative 3, 8 will be up here, negative 2, 4 will be here, negative 1, 2 is here, 0, 1, again, they still share that point. 1, 1/2, 2, 1/4, 3, 1/8, and now I'm going to come down like this, and I'm going to get closer and closer to my x-axis, but never touch it. So in this case, my x-axis is still going to be my asymptote, which I will draw in with a dotted line. And now you can see that this here we now call exponential decay, because this represents numbers that start high and quickly go lower. If we would graph these two functions on the same graph, the y equals 2x that we had originally and this one, you can see that they actually would be just reverse of each other. They'd be symmetrical to each other. That one would kind of come like this, come like this, down and around like this. So this one here would be my exponential growth, y equals 2x, and this one here would be my exponential decay, y equals 1/2 raised to the x. So to kind of summarize that, they are symmetric about the y-axis. Anytime these bases are going to be the same, one here, b to the x, and 1 over b, they'll always be symmetric. If the b value is greater than 1, then we have exponential growth. And if I have some fraction here less than 1, then I'm going to have exponential decay. So for instance, if I had y equals 3 over 5 raised to the x, that would be decay. However, if I had y equals 7 over 3 raised to the x, that is a fraction, but it is not less than 1. So this here would still be growth. Remember that I can write y equals 1 over b raised to the x can also be written as a negative exponent. So you need to recognize that these are actually equivalent statements. In the next video, we're going to talk a little bit about shifting graphs, so please watch that if you are